Hello and welcome to another video of the series of ground-based infrared telescopes. Today we'll talk about the UK Infrared Telescope UKIRT. As always, first I will tell you about history and purpose or motivation of the telescope, then the equipment, geography, some of the results as far as I could get them, and a summary or outlook. History and motivation of the UK Infrared Telescope. It has been operated by the Joint Astronomy Centre in Hilo on Hawaii and was owned by the United Kingdom Science and Technology Facilities Council. And it has been built in the 70s by companies from the United Kingdom, Dunford Hatfields, and mechanics by Group Parsons. For the mechanics and Group Parsons for the optics. And the operations began in 1979. Then from 2010 there were no astronomers in the observatory, so it was automatized and steered from Hilo for survey work, and 60 nights per year were used by Korean institutes. Then, unfortunately, it has been decommissioned starting from July the 7th, 2025. They said it will be replaced by the 30 meters telescope, although the 30 meters telescope is still a bit unsafe. When is it gonna come and where is it gonna be, and if it's gonna come, because the money collection is not very far and there was lots of opposition in Hawaii against the 30 meters telescope, so the people who want to build it, they have found an alternative place to put it, so it's not even clear if it's going to be there. We'll look at the map later and see if the 30-meter telescope could be right in the place where UKIRT is or not. The aims of these infrared telescopes were to make a large sky survey, the UK IDSS. But it also found, for example, a quasar, the most distant quasar, in 2011. The equipment it's quite a large telescope with a diameter of 3.8 meters, which is 150 inches. And it is a Cassegrain and used to be the second largest dedicated IR telescope in the world. Wavelength range was from 1 to 30 microns. And here I listed some of the instruments that it had. For example, several different spectrometers, and also a wide field camera. Here they write at forward Cassegrain with a 2048 times 2048 array CCD. But they said in another place it was looking against the primary mirror, so probably the wide field cam didn't use the secondary mirror but just looked directly to the primary mirror. That's why it had a very wide field. Good for service. And during the long time it was working, there were improvements made. So the resolution it could reach were 0.8 arc seconds in the evenings and 0.5 seconds in the mornings. It's quite interesting to have this number for comparison with other telescopes. And the seeing in the infrared, which is probably not the same as in the visible range. Then the geography. This is very famous, the peak of the Mauna Kea, which is here, and there are lots of well-known telescopes up there, and they're all basically on the same level, connected by this road, this ring road. So the submillimeter array is down there, up there, and the James Clerk Maxwell telescope is up there. Then the Subaru telescopes by the Japanese. Subaru is Japanese for the Pleiades, the Seven Sisters. And by the way, the Subaru telescope is the only one that you can visit and use as a layperson for an hour or so up there, in case you're around. And then there are the two Keck telescopes, the 10-meter telescopes. And then the infrared telescope facility. I will talk about this one probably in my next video. And here is the Gemini North telescope, also in Hawaii, whereas the Gemini South telescope is in Chile. And the one here I'm showing here, that's the UK Infrared Telescope. So I announced that it is not clear if they commissioned this building here, if they will be able to build the 30-meter telescope here, because it may need a bit more space, I think. But it's also possible that there's an agreement that they can have a certain amount of telescopes up there, and that they have to destroy one before building up a new one. I don't know. But the fact is that they started decommissioning this UK infrared telescope. We'll talk about this at the end of the presentation. The other thing I always point out when we look at these ground-based infrared telescopes is the wind belt where the telescope is situated. This one is at 19 degrees north, which is actually perfect. There's no better place when it comes to being in the eternal high pressure zone. Whereas there is often nebula around on top of the sea in Hawaii, and this makes it even better if you have fog below you. The sky will be even better, and it's at more than 4,200 meters up, or 13,800 feet. That's really good for an infrared telescope, because the higher up the better. Some of the results, I couldn't find many images actually in the internet. It has been used for observations of comet 9P Tempel. This was the comet that has been visited violently by a probe during the Deep Impact mission. But this picture is of this comet, but not by the UK Infrared Telescope. Same for this picture, of course, which has been made by a probe. But the UK Infrared Telescope did help to observe what was happening when this impactor smashed into the comet 9P Tempel. It's very interesting because people are still discussing what is a comet made of. Dusty snowball, how much dust, how much snow, or is it a special, are they hollow, or is it a special form of ice with lots of air inside, maybe CO2 and CO also, despite water. That's what this impact was made for, not actually to bring the comet to a new trajectory or something, just to look what is inside. Then it did a survey of the sky it could see, and this is just an example picture of the test phase, which is of course Orion Nebula M42 in the infrared. But I don't have many other images apart from that. It also worked to observe microlensing events in the Milky Way, and there worked with other telescopes, for example the Spitzer telescopes that I explained in another video. And it also observed exoplanet light curves. But it used automatic readouts, I think, so the pictures maybe were read out without being published. And here you can see how many million light curves that these were from year to year in the H band and in the K band. So this was a really important part of this telescope, besides the survey, to take pictures of the same places in the sky again and again and make these light curves. You can look, if you're interested, you can look that up in the Exoplanet Archive page. And also star formation was observed. Here there's a false color image of a massive star forming region. And the interesting thing is this was done by a spectrometer that makes images. And the image was overlaid with a visible range image. So they could look at molecular emission lines, and the red spots you see here are these molecular gases coming out while the star is born. Stars being born is a very complicated process that doesn't go as smoothly as people thought in the beginning, so materials can also be spat around a lot. And something that the telescope also did, which fits quite well to this exoplanet thing, is tracking variable stars in the near infrared. And this is an example of a part of the sky where there were variables observed with the UKInfraredTelescope. And if you're interested in the publication, this is by Meng et al. And I found it in archive. So as a summary, why has it been discontinued? As I told you, one thing was this political thing that people want to set up the 30 meters telescope, and it for politics there was probably this thing, make a new telescope, destroy an old one. And the tendency goes towards larger telescopes, especially for spectroscopy. So maybe that was also a reason why the project ended. And the other thing, of course, is that infrared can be measured on any large telescope. So why have specialized infrared telescopes? The survey was maybe finished, so it was good to have a telescope that was quickly ready for special observations, but just for that you won't probably finance such a large telescope, but maybe just measure on another telescope. Actually, I think at ESO in Chile there are lots of smaller telescopes that are not in regular use anymore. So astronomers book time on telescopes as large as possible, and the smaller ones are not as regularly used then. But often they don't use much work on them, so they still stand there. A 1 meter telescope, for example. And these are two more views of this observatory. Very characteristic on these cupolas are these windows. These are to reach the around temperature quickly when the night starts. They can be opened for that. Thanks a lot for the attention.